welcome back to Learn Extra. Remember guys, helpdesk@learnextra.co.za is our email address. 086 10 58 262 is our telephone number. Now, the next question was phoned through by a gentleman by the name of Goodwin. Hello, Goodwin.
Hello, how are you?
I'm very well, thank you, and yourself. So, Goodwin, you say that this question is from the DBE paper 2, November 2010?
Yes.
Okay. Okay, Goodwin, I need you to just turn the volume on your TV off and to listen to me over the phone and speak up a little bit.
Okay.
So while Goodwin's doing all of that, let's have a look at this question. Now, the question says the line LP with equation y plus x minus 2 equal to 0 is the tangent at L.
Yeah.
So, Goodwin, I've just written it onto the graph there, so it's that tangent over there. Let's just make sure we know all the information. Then they say the circle has a center M, which is -4 and 4. Yeah, that's drawn on. Ln is the diameter of the circle, and also that LP and NQ are parallel to each other. Right.
Yeah.
Okay, so the first question is for us to determine the equation of the diameter Ln. So we need to find the equation of this line that I'm highlighting in green. Now, Goodwin, have you got any ideas for me? Where are we going to start? What are we thinking about?
What I know is the equation of LP, which the gradient is -1. And
The gradient is
the
-1.
radius.
Okay,
Yeah.
that's brilliant. Let me just, not everybody might be as quick as you, so let me just do that quickly. I'm putting the equation of that tangent into standard form.
LP.
Okay. So what Goodwin, what you're saying is that the gradient of this tangent is -1.
Yes.
Okay. Which means,
And
carry on.
The radius is perpendicular to that line.
Yes. So the gradient and the tangent and the radius is perpendicular to each other. That's correct.
Yeah.
So that means that what is the gradient of my diameter?
The gradient of Ln is going to be a positive half.
No, it's not positive a half.
No?
It's positive 1. Because
Yeah, it's positive 1.
Yeah, because the
Because
gradient
it's
of the tangent.
-1 multiplied by 1.
That's absolutely right. Okay. So what I'm going to do is I'm going to write down the formula for the equation of a straight line, which is y minus y1 is equal to mx minus x1. Right.
Yeah.
Okay. So this is going to be y minus 4. I'm substituting in the center of the circle because the center of the circle lies on the diameter. And then my gradient is 1. And then x minus 4.
Yeah.
Okay, so far so good. Not too bad. And I have y is equal to...
Negative multiplied by negative is positive.
But hang on, it's not negative. So this is going to give me x minus 4, but I've got minus 4 over here as well.
Yeah.
So the equation of this line is y is equal to x. Are you following me? I just want to see if I've substituted this in correctly.
Yeah.
Oh no,
Yeah, I understand.
Just hang on a sec. No, let's wait a minute. Okay, so the gradient of our diameter is 1. Now
It's 1.
so then it's going to be y minus 4. Sorry, and this is x minus 4. That's plus 4, right? That's where I went wrong. It didn't look right.
Yeah.
And then I'm going to get y is equal to x plus 8.
Yeah, y is equal to x plus 8.
Okay. And that looks better because what I was getting when I got my signs messed up is I got y is equal to x. Now, Goodwin, the line y is equal to x would lie over here, and I knew never in a million years would that work. Okay, so Goodwin, you did brilliantly on that. So we know that the equation of our diameter is y is equal to x plus 8. Right, so let's have a look at the next question. The next question asks me to calculate the coordinates of L. Calculate the coordinates of L. So, Goodwin, looking at our diagram, what is L?
L is our tangent. It's a point that touches the circle.
It's the point that touches the circle, but at this point in time, I don't know the equation of the circle, but L is also the place where my two straight lines intersect. Okay?
Sure.
So I need to find the coordinates of L. So what I'm trying to think now is I'm trying to think of how am I going to do it. Now, I don't know the equation of the circle, so that helps me very little. So do you agree with me that I need to find the points of intersection of these two straight lines?
Yes.
Okay. So how do I find the points of intersection between two straight lines? I'm going to put them equal to each other, right?
Yeah, it's all smart enough.
Right, so let's do that. So I've got y is equal to x plus 8, and I've got y is equal to negative x plus 2.
Y equals to x plus 2.
I've just put this one into standard form. Now I'm going to put the two equations equal to each other. So x plus 8 is equal to negative x plus 2. Are you happy so far, Goodwin?
Yeah.
Okay. So what am I going to do next?
Going to transpose that x to the other side.
Nice. And then it will become 2x. And the 8?
2x. And the 8 to the other side is going to be
negative.
Negative 8.
Okay. It's going to be negative 8,
Plus
you're quite
2.
right, plus 2, and that gives me minus 6.
Yeah.
All right. And we get that they intersect where x is equal to negative?
X is 3.
Negative 3.
We divide both sides by 2.
Yeah, so both sides by 2, then I get x is negative 3. And
Okay.
what I always do, Goodwin, is I go back to my diagram. I know it's not drawn to scale, but I have to get something that looks realistic. And x equal to minus 3 looks quite cool to me. Are you happy with x equal to minus 3?
Yeah, I'm happy.
All right. So if x is equal to minus 3, how am I going to go about finding the y value?
Finding
The y value.
Substitute the point 3 into x.
Absolutely.
Into the original equation of the line of LP.
Yeah. Into either one of the two lines, it should give me exactly the same answer. Are you happy with that? And it gives me, if I put, okay, so this is negative 3.
So
And negative 3 plus 8.
3 plus 2, which is 5.
That's 5. Okay. Goodwin, you can't put the volume of you have to listen to me over the phone. If you're going to listen to me over the TV, then it's going to sound all funny, okay?
Okay.
All right. Okay. Now, Goodwin, you're doing really, really well so far. You haven't had too many problems with this question. Tell me, Goodwin, where are you phoning us from today?
I'm phoning from Gauteng.
From Gauteng. And are you feeling ready for maths?
Yeah, I'm feeling ready.
Okay. Now, Goodwin, the next thing that you and I need to do is we need to determine the equation of the circle. Okay? We need to determine the equation of the circle. Now, that's not too difficult. First, what I'm going to do is I'm going to write down the general equation for a circle not centered at the origin. So that's x minus a, everything
Y minus
squared. Yeah. And y minus b squared. Okay, now Goodwin, I want you to talk me through it. It's your question after all. What am I going to do now? What am I going to do now that I have this equation written down?
In the space of A and B, you're going to use the center of the circle.
In the places of A and B, I'm going to put the center of the circle. Absolutely right. So let's do that. So this is going to become x plus 4 squared
y minus 4 squared.
Okay. Now, the only thing that I don't have for my equation of the circle at this point is I don't have r. So how am I going to find r?
I think we need to work through the brackets.
Okay, what I'm going to do, what I'm going to do, Goodwin, is I'm just going to substitute that point into the places of x and y. You can substitute any point that lies on the circumference. Funny, what some people do is they will apply the distance formula to that. Guys, that's too much trouble. Don't do that. Just substitute the point into the bracket. Right. Goodwin, tell me the substitution.
The substitution?
Yeah. So what am I going to, so tell me what I'm going to put in my brackets.
You can use the point L.
Yes.
Then it's going to be -3 plus 4 squared plus, then we have y, which is 5.
Yes.
Minus 4 squared.
Absolutely.
Then equals to squared.
Okay, lovely. So then I get -3 plus 4, which is 1. 1 squared is 1. I get yet another 1. So I get r squared is 2.
It's 2.
So that means that the equation of my circle, and I've got to write it all out nicely together. The equation of my circle is x plus 4 squared plus y minus 4 squared is equal to 2.
2.
Okay. Now, Goodwin, I'm interested to know where your problem was with this question, because you seem to be doing very, very well, if you ask me.
I think I was in your hand. That's why I made quite mistakes somewhat.
You're going to have to speak up a little bit, Goodwin. What were you saying? You think you were?
I was in a hurry.
In a hurry. Yeah, it pays to keep a calm head when you're doing maths, really. Okay, so let's have a look what the rest of the question has in store for us. So I've done that bit. I've done that bit. It asks us to write down the coordinates of n. Okay?
Yeah.
Now, Goodwin, what are your ideas on that?
They said the information on the top, they said LP and
Goodwin, I'm really struggling to hear you. They're asking us to write down the coordinates of n. What are you saying?
I think we have the LP and NQ, which is a parallel, so they have the equal gradient.
The two are parallel, so they've got equal gradients. Yes, but Goodwin, when they use the word write down, they don't really think that we're going to be doing a calculation. So usually when we are told write down, we must use symmetry.
Symmetry. Or the rule of transformation.
Yeah, something like that. But by symmetry, because this is a circle, you can, I mean, if one is not sure, you can always check. But this is going to be -5 and 3.
Okay.
Okay. All right. Are you happy with that? If you don't believe me, you can substitute it onto this line. But write down usually means just that, write down. It doesn't mean do a long calculation. If we have to get into parallels and things like that, it's going to take. It's just going to take too long. Okay.
The problem, I'm checking the marks. They say it write down and it's 3 marks.
Yeah, it's 3 marks. It's 3 marks. Yeah.
Yeah.
Okay. Now, then it asks us to write down the equation of NQ.
Yeah.
Okay. Now, I think what are your thoughts on the equation of NQ? Goodwill? The lines are parallel. We've already said that.
Yeah.
So we
Yeah,
do
we
know
have
that the
this,
line's gradient is
-1.
-1. Okay. Now, I would say that the equation is y is minus x plus 2.
Okay.
But you don't have to believe me. You can also use, just because that one is at 2, so then by symmetry, because of the circle, then this would be -2. Okay? But anyway, we can
Yeah.
substitute in this point as well. Okay?
Yeah.
All right. Right, so I want to actually just get to the last question because I think this is a really cool one. So if you'll forgive me, let's skip on to 6.6 so that I don't have to rush through that one. Now,
Okay.
they say to us, if the length of the diameter is doubled and the circle is translated horizontally 6 units to the right, give the equation of the new circle. Now, the first thing that we need to say is, Goodwin, the center of the circle is going to move. Do you agree with me?
Yeah, it's going to.
Because it's translated 6 units to the right.
Right.
Okay. So, what am I going to be messing with? I'm going to be adjusting that. Okay, so if it's translated 6 units to the right, have a look. What I'm going to do is I'm going to say it becomes x plus 4, right, minus 6. Are you happy why it's minus 6?
-6.
Yeah. Are you happy
because
that
it's
-6 means 6 units to the right?
Yes.
Okay. Squared. Plus. Okay. Now the y's are not changing. It's staying the same, right? So that's just going to be y minus 4. Okay. Now, Goodwin, if the diameter is doubled, what happens to the radius? The radius is also doubled, right?
Double.
Okay.
Yeah.
But now we must be very careful in the case of a radius. Don't work with the radius squared. Work with the actual radius. What is the radius of this circle?
It's 2.
No, it's not. The radius squared is 2. So what is the radius of the circle?
Square root 2.
It's square root of 2. Okay, so at the moment, before this doubling business, the radius of my circle was root 2. Right. Now I am doubling it. So my new circle's radius will be twice that of the previous circle, right? So this is going to be 2 root 2, right? And now, Goodwin, when I put it back into my equation, what I must remember is that the equation asks for r squared, right? Okay? So what am I going to, so quickly square 2 root 2 for me. Tell me what is 2 root 2 squared.
What?
Quickly tell me what is 2 root 2 squared. So do that for me. Square it.
2. Okay.
You shouldn't have to use a calculator.
It's 8.
Okay. So how did I know that? I said root 2 times root 2 is 2. 2 times 2 is 4. So in my equation over here, I'm going to put 8. So often, Goodwin, what people do is they say the radius is doubled. And then they just times by 2 there, and then they say, oh, now it's 4. Okay. It doesn't work like that. What you've got to do, guys, is write down the actual radius. So square root the radius squared, then double it, and then square it again and put it back. Does that make sense to you, Goodwin?
Yeah, it makes sense.
Okay. Now, Goodwin, they didn't ask us about this, but how would the areas of the original circle, the green one, compare to the area of the new circle? By the way, this I could just tidy this up. I could just do that, just write it nicely. How will the areas... Now, what has happened is that the radius is double, right? So what effect is that going to have on the area of the new circle? Is the area of the new circle also going to be double?
Yeah.
No, it's not. Okay? I want you to think of this. The area of a circle is pi radius squared, right? Now for our first circle, my radius was root 2. So it's going to be pi root 2 squared, which is 2 pi, right? Now for my second circle, the radius is 2 root 2. So it's going to be pi times 2 root 2 squared, which is going to give me 8 pi. So if I look at the relationship between the area of the one to the area of the other, this one is 4 times bigger. So Goodwin, there's a good tip for you. If the radius is doubled, the area will be 2 squared, 4 times bigger. If the radius is made 3 times bigger, then the area will be 9 times bigger, and so on. Okay? Are you happy with that, Goodwin?
If it's 2 times bigger, it's going to be 4 times bigger.
Yeah.
If it's 3, it's going to be 9.
Okay, and if it's 10, if the radius is 10 times longer, what is going to happen to the area?
It's going to be, this is going to be 15 or 20.
No, it's going to be 100. What I need you to see is if the radius is made double, then the area is 2 squared. If the radius is made 3 times bigger, the area will be 3 squared, which is 9 times bigger. If the radius is made 10 times bigger, then the area will be 10 squared, which is 100 times bigger. Okay. So that's a very that's something that is often asked. It wasn't asked in this question, but it's something that is often asked. Okay, Goodwin, I hope you're feeling a bit better. You're sounding a little bit asleep. You know what you're doing, but you sound a little bit like you're very tired.
No.
All right. Okay, so Goodwin, can we quickly summarize just the translation of circles before we finish? Okay. I'm going to give you one more because you sounded a little bit unsure of the last bit. So I'm putting an equation of a circle on the board for you right now. Okay. And I'm saying to you, Goodwin, I am doing 2 things to this circle. I am moving it up 2 units, and I'm making the radius 3 times longer. Now I want you to tell me what is the equation of the new circle. I'm taking that circle, I'm moving it up 2 units, and I'm making the radius 3 times longer. Okay. So first tell me what's going to happen with the moving up business.
It's going to affect the y.
Absolutely.
Side, which is going to cancel.
No, but we're dealing with a circle. We're dealing with a circle. So up is actually minus.
Yeah,
remember the circle?
To be
x
plus 1 all squared.
Yes.
Plus y squared.
It's not y squared. In a circle, if we move up, and it's only for a circle that this is true, because a circle is not a function. I put in minus 2 to move it down, only for a circle. For anything else, parabolas, hyperbolas, all of the functions, if I say plus 5, it'll move up 5. But for a circle, no, that has to be a minus, okay? Okay, so this becomes y minus 4 squared, okay? Okay, now, what are we going to do about this 3 times longer? I first look there and I say, right, the radius at the moment is what?
It's 4.
No, it's not. The radius squared is 4. The radius is 2.
2.
Okay. Then I take my radius of 2 and I multiply it by 3 because I'm making it 3 times longer. Okay, so the radius is now 6. And then when I put it back into my equation, I square it and then it becomes 36.
36.
Okay.
Yeah.
Okay. Thank you, Goodwin. You've been a real sport. And guys,
Yeah.
with that, that's the end of our hour and a half Maths Learn Extra show. But guys, do stay tuned. We've still got science, we've got life science, and we've got maths literacy coming up. So take a quick break and then be right back for the science lesson hereafter.